This worksheet deals with sine and cosine ratios predominantly. If something a tangent might creep in. Just have to see how it works out. Sorry about that. Okay, so let's see what we have here. So sine is opposite over hypotenuse. So if you have a triangle, and let's say you know how tall something is, it's opposite side, but you don't know the hypotenuse, but you do know the angle, that would be a sine problem. Or some combination of two of those. Let's say you know the angle, you know the length of the hypotenuse, you can figure out what the opposite side is. Or if you know the angle on the opposite side, you can figure out the hypotenuse. If you know the opposite side and the hypotenuse, you can figure out the angle. Okay. Now for cosine, we're dealing with adjacent side. So triangle with the cosine might be the adjacent side. Here's the angle again, and here's the hypotenuse. So if you know the angle in an adjacent side, you can figure out what the hypotenuse is. If you know the angle and the length of the hypotenuse, you can figure out what the adjacent side is. Or if you know the hypotenuse and the adjacent side, you can figure out what the angle is. Okay. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So the sine gives us the SOH part of SOHCAHTOA, and the cosine gives us the CAH part of SOHCAHTOA, and the last sheet we did have the TOA part of SOHCAHTOA. Some old hag came around here to offer apples, is the Disney version. So look at this example. So you have to find the sine and cosine. So sine of x, again, find the hypotenuse first. There's the hypotenuse. So opposite side to the x is 12. Hypotenuse is 13. So sine of x is going to be 12 over 13. Now for cosine of x, we have adjacent side, which is the 5, over the hypotenuse, which is 13. So 5 out of 13 is the cosine of x. If we're looking at y, we have opposite side is now 5, hypotenuse is still 13. And for cosine, we have adjacent side, which is 12, over the hypotenuse, which is 13. So all we have to do on these is find the ratios that go with these. Some of these I'm going to look up in a table, or I could just use a calculator set for degree mode and just find the values that way. I happen to have the table handy. So let's see, we want sine and cosine of r. So here's our angle r. Find the hypotenuse first. There's our hypotenuse. So in relation to r, this is an opposite side. This is an adjacent side. Let's go ahead and do the rest of these while we're at it. So over here, here's r. 9 is opposite. 12 is adjacent. 15 is hypotenuse. Over here's our r. Change colors up. Here's our r. Hypotenuse is the 10, opposite. 5 root 3, adjacent, 5. And this one over here, here's our r. The hypotenuse is 6, opposite 3 root 2, and adjacent 3 root 2. Where these are both the same, we know it's isosceles, right? We know these are going to be 45s if we need to find the angle. So express the ratios. Do these in red. Let's see. Sine of r, opposite over hypotenuse, 24 over 45. And cosine of r equals adjacent over hypotenuse, I told you wrong on this other one here. This should be 51 for the hypotenuse. Got to be careful about the hypotenuse. And for cosine, we have adjacent, which is 45. over hypotenuse, which is 51. Okay, let's look at number 2. Sine of r is opposite, which is 9 over 15. So that's going to be 3/5, 0.6. And cosine of r equals 12 over 15, which is 4 over 5, which is 0.8. Let's look at number 3. The hypotenuse was... Can't read the hypotenuse. Let me see. Well, hypotenuse is 10. Okay, so sine of r, we have opposite, which is 5√3 over 10. So 5 comes out the top and the bottom, √3 over 2. Cosine of r is adjacent to the r, which is 5 over 10, which is 1/2. Let's do number 4. Sine of r equals opposite over hypotenuse, which is 3√2 over 6. So 3 goes in the numerator and denominator, we get √2 over 3. And cosine of r is the same thing, because we got the same ratios, √2 over 3. Okay, let's look at these here. Cosine of 22, using a table of values for cosine. I'm going to look up cosine 22, and 22 cosine 0.9272. Sine of 79 degrees, go to 79, find the sine column. We have 0.9816. Cosine of what is 0.7771. I'm going to look down my cosine column to find the closest thing, and it comes out to be 39 degrees. Number 8, 0.8746 is a sine. 0.8746 comes out to be 61 degrees. 0.3891 is a cosine. 3891 cosine. Okay, 3746 is 68 degrees. 3907, which is closer, is 67 degrees. So this is just a little bit more than 67 degrees. And 0.5321 for sine. 0.5321. The closest appears to be 5299, which is 31 degrees. So this is about 31 degrees. A little bit 5321. A little bit bigger than 31 degrees. Say that right? Wait, hold on. 5321. It's a little bit bigger than 32 degrees, sorry. It's a little bit bigger than 32. Okay, let's look here at these values. We want to find these to the nearest integer, and I'm just going to set the ratios up, and you'll have to finish them off. I want to find x and y. So we want to find x. X is an opposite, and we have a hypotenuse of 34. So we would say that sine of 52 equals x over 34, or 34 times the sine of 52 is going to be x. Let's look at number 12. So 70 is our reference angle. Oh, we also have to do y. Sorry about that. Let's go back and finish number 11 for y. Now, if we want to find out what y is an adjacent side with the hypotenuse. So we say cosine of 52 is equal to y over 34. or 34 cosine 52 equals y. Okay, let's look at number 12. 70 is our angle, x is opposite, hypotenuse 75. So sine 70 equals x over 75, which means that 75 times the sine of 70 is going to be x. Now to look over the y. Y is an adjacent side to the 70, so that's going to be cosine. Cosine 70 equals y over x, same steps, equals y over 75 rather. And so 75 cosine 70 is going to be y. Let's look at number 16. 43 is our reference. Y is opposite. X is adjacent. So that's going to be cosine for x. Cosine 43 equals x over 16. Or 16 cosine 43 equals x. Now for the y is an opposite. We have opposite hypotenuse. This can be sine. Sine 43 equals y over 16. Or 16 sine 43 equals y. For the last one on this page, we have 24 as our reference. Y is opposite, x is adjacent. So sine 24 equals y over 10, which means 10 sine 24 equals y. And for x, it's an adjacent. We have cosine 24 equals x over 10, or 10 cosine 24 equals x. And they want this to the nearest integer. These need to be simplified. Let's look at side 2 now. Here we're finding values to the nearest integer again. So let's see what they're doing here. Isosceles, he wants to find out what x is. So x is the side length. It's isosceles, that means there's a side length there. I'm going to call that one y. We want, and again in this triangle, that's going to be bisected. So we could do something about sine of 55. Now cosine of 55 equals 7 over x, and figure out what x is that way. And if we want to figure out the altitude, that's an opposite. We could do cosine. We do sine 55 equals y. We can't really do that though. If we have a 55-degree angle here, we have a 7, which is an adjacent. We can figure out the hypotenuse by doing cosine 55 equals 7 over x, which means that 7 divided by cosine 55 is going to be x. Now to find out what y is, though, we have to use tangent with what we're given, or the Pythagorean theorem, once we know what y is, or once we know what x is, because we have an opposite and adjacent set that we can deal with. So that's going to be a tangent 55 equals y over 7, or 7 tangent 55 is going to be y. This is what they did over there. Okay, so you can look at that. Let's look at these others. Number 15 here. Let me maybe not zoom in. So if this is isosceles, this piece here is 22, as is that piece. So we have a 75 and adjacent side is 22. We want to find out what x is. That's the hypotenuse. So we could say we have adjacent with hypotenuse. Cosine of 75 equals adjacent, which is 22, over hypotenuse, which is x. So ultimately, x is going to be 22 divided by cosine 75. That gets our x. Now if we want to find the y is an opposite. And we have an opposite with an adjacent in the triangle that we're given without using a calculated value. So To find y, the way the problem is set up, I would actually say tangent 75 is equal to y over 22, which gives us 22 tan 75 equals y. Let's look at number 15. I think we got a 6 for the altitude. Now, in relation to the 47, 6 is an opposite side, and we have like 1/2 y there, 1/2 y here, in case we need to think about that, and we got isosceles right. So we want to find out what y is. So using the triangle set up like this, we have an opposite with an adjacent. It's going to be a tangent problem. Tan 47 equals opposite, which is 6, over adjacent, which is 1/2 y. Multiply both sides by 1/2 y. So we have like basically tan 47 over 2y equals 6. Multiply both sides by 2y, tan 47 equals 12y. Divide by 12, y is going to be tan 47 divided by 12, whatever that ends up being. Now to find out what x is in this one, x is a hypotenuse. So using 47, we have an opposite with hypotenuse that we need to deal with. So that's going to be a sine problem. So that's going to be sine 47 equals 6 over x. And ultimately, x is going to be 6 divided by sine 47. That's how we would find number 16. Okay, I'm going to skip over 17 because there's not room. Let's do number 18. So let's see, we've got a y. That's going to be a y. If that's a 60, that's going to be a 60 because it's isosceles. That means this is going to be a 30. This is going to be a 30. And there's lots of stuff we can do now. So we got a 60-degree angle as our reference. 15 is opposite. Hypotenuse we don't know. So I could say sine of 60 equals 15 over x. So x is going to be 15 divided by sine of 60. Now if we want to find out what y is, which is this piece right here, this is an adjacent side. And we have an adjacent, without using calculated value, we have an adjacent with an opposite. That's going to be a tangent. Tan 60 equals y adjacent over opposite, which is 15. So this is going to be 15 times the tangent of 60 is equal to y. So look at these on the bottom here. We want to find the degrees. So I'm going to use, well, I'll just set it up, and then it'll be up to you to use the table or calculator to find out what's the closest. In relation to what we have here, we have an opposite with a hypotenuse. That's going to be sine. So sine n is equal to 19 over 21. And n is going to be sine minus 1, which is second sine or shifted sine of whatever 15 divided by 21 is as a decimal. And that will give you the angle that you need. Okay, let's look at number 20. We'll set that up. N's our reference angle. This is a hypotenuse. This is an adjacent. This is going to be cosine. Cosine n equals adjacent 37 over 60. So cosine minus 1, n is going to be cosine minus 1 of 37 divided by 60. So number 12 is in degrees, x degrees. This is going to be 7, this is going to be 7, this is going to be 12. Let's see what we got. We want to find out what x is in relation to the angle. So we don't know what the angle is, so we have to use something that we're given. To find the angle, we would have to actually use tangent. We would use cosine, which is 7 over 12. So we say cosine n equals adjacent, 7 over 12, which is hypotenuse. So cosine minus 1 of whatever 7/12 is going to be our n. And once we find out what the angle is, to find x, we have an opposite with adjacent. So we would say sine of wherever the angle number is. So this is going to be some number. So sine of whatever this angle is going to be x over 12. Or 12 times the sine of whatever that number is that's supposed to come from 1 before is going to be equal to x. The last one on this page, that's going to be a 6, that's going to be a 6. And we got everything else. So to find out what x is, we got an n and an x. We only have really one unknown at a time to deal with. So we got a 6 and a 10, which is an adjacent hypotenuse with the n. So that's going to be cosine n equals adjacent, which is 6, over hypotenuse, which is 10, or 0.6. So we can easily do cosine minus 1 of whatever 0.6 is, and that's going to give us the angle measure we're looking for. Equals n. Okay, to find out what x is with what we're given, can we really do that? I think we have to know what this angle actually is before we can actually use two of these at the same time. So once I know what my angle is here, now I'm going to do we're looking for x now. So that's going to be opposite over adjacent. So we could say sine, or that's going to be tangent, opposite over adjacent. Tangent of whatever the angle measure is that we got from above is equal to x over 6. 6 times the tangent of whatever that was is going to be equal to the x that we're looking for.